Good morning, everyone. Ladies and gentlemen, after a gap of 40 days, we are back again on the webinar floor. And as usual, we are coming out with various topic which we feel is necessary for improving our knowledge, specifically on electrical fire and security. So we keep coming out with different subject. So on behalf of my team, Blue and Grey and Sonel India, I warmly welcome all of you for today's topic, power quality. Very important that I'm also a learner in this whole process. So we delighted to see such fantastic response we have. We have over 500 registrations, and I'm sure that everyone's going to attend. And this participation is coming from all across, not only in India, from Middle East, from the Europe and the Far East also. I can see people joining from Vietnam, Philippines, and all that. So it shows the interest on the topic. So we have, as usual, the fantastic, very charming speaker we have. I will introduce you in a while. So looking forward, the reason why this topic we have chosen, maintaining a reliable, efficient power system is cornerstone for any modern infrastructure. Today in today's session, we will highlight the challenges, innovation, and practical solution in power quality management, an area that directly impact safety, productivity, and sustainability. I'm sure that Mr. Shyam going to throw a lot of new, points, new standard, how it is evolving over the period in the fast-changing technology. And I'm requesting everyone to pay attention. I know webinar when you do online webinar, attention level is very very remote. So the speaker will stay, short, and we take many questions. I would like to see questions coming in. There is a Q&A box just below the banner you can see on the screen. There is a Q&A box. I request everyone to put your questions only in Q&A box. Though we keep repeating, people come far, put their question in the chat box. That's not going to help us because that will not go on recording. So maybe we can't take all the questions. We always, after the webinar, we go through the questions that is there in the Q&A box. We try to answer. So I request humbly, please post that in the Q&A box only. And those who want to speak to the speaker, you can raise. There is a raise hand symbol. You can post it after the presentation. I will, depending on the questions, I will allow you to speak. And also those who wants to give testimonial or people who want to share their experience on power quality, also most welcome. And I would request you to raise your hand. It becomes easy for me to identify and allow you to come. So coming back, Shyam Ravindran, now the face of measurement in India, he is traveling with us for various workshops. Spending at very young age, he is sharing immense knowledge to the country. He had a chance to settle down in Europe, but I know about Shyam. He chose to come back to the country. He loves India and he wants to contribute to the development of the nation. So, with 15 years of experience in electrical testing and testing and measuring across India and Europe, Shyam Ravindran leads Sonel India as its managing director. He played an important role in establishing Sonel footprint in India and driving its growth across emerging market. As I see, they are the most leading and most popular brand today in India when it comes to measurement. And I'm so happy to see wherever I go, I could see the tool they use is always Sonel. So I'm a fan of Sonel now. So Shyam, the speaker, he holds the master degree in electrical power engineering from WT Poland, and is a certified professional in thermographer, and also published various technical papers, including contribution at CARED in Sweden, As a seasoned leader, he brings deep expertise in power quality and electrical safety testing. With passion to innovation, strategic growth, and being a managing director, delivering scalable solution for modern electrical system. So this is our speaker for today, Shyam Ravindran, Managing Director of Sonel. Myself, Dominic, I've been in the fire industry for 36 years. Continue to share knowledge on safety standard through article and webinars. So my face is quite maybe familiar with many of you. I will not bore you with my introduction. So I will now welcome Shyam to take the center stage of this today's topic, and let's make very engaging. We have a fantastic turnout today, and it shows the importance of our quality. I would urge you to put your questions only in Q&A. And we also coming with next series with Shyam, my colleague on the chat box. She will mention the link and all that. Please do in contact, and we'll come back again after we finish the question answer. Over to Shyam.
Okay. Is my screen visible, Mr. Dominic?
Yeah.
Okay. Thank you so much for your kind introduction. But before we begin the session, I again want to, make a quick applause to your entire team. 500 plus registration in a topic of power quality. This is not, I'm not sure if it is even real, but that is the level of, activities that is pulled out by the team. Extraordinary job. So kudos to your entire team, sir. So this,
Thank
I'm sure that without your team support, this wouldn't be possible to even conduct this webinar at that scale. So thank you again for the introduction and also the spot with such lovely audience. Yeah. Thank you so much.
Thank you. Thank you,
Now,
Shyam.
thank you. So we'll move today to the topic of power quality. The title, as I've kept title, I'll say in a broad way, where I will want to talk about the measurements and reporting in IEEE 519, and also the solutions, some of the solutions, what is recommended for a PQ problems. So in this session, when we talk about recording, though the standard remains the same, how the customers approach the recording from the data point of view, that is something that is not very specific in the standards, but we can talk how this is utilized by the different set of customers. I mean, different setup. What I mean is how the utility wants the reporting to be done, how the final customers want the reporting to be done. So we can talk a brief about those scenarios. And this is power quality is always addressed to, I will say, emphasized, regularized to mostly towards the customer end. There is a clear borderline between the utility and the customer and the new regulations. Having said that, this is only possible only when the customer addresses this problem at scale. So we will talk briefly about the solutions, PQ issues for the customers, and I'll very quickly shout out the agenda. Yeah? So I'll briefly introduce about our company, and like in any other sessions, we wanted to first to talk about what are the standards. We wanted to cover it up. Then we'll move into power quality definitions and fundamentals. I'll show you a couple of analyses. Again, this is where the total dynamics of the measuring equipments will change, because for the utility perspective, for the final customer's perspective, we'll talk briefly about the PQ solutions. And we also, for the customer case studies, we also have invited our customer from railways. He wanted to share some of his case studies by the end of the session. So let's try to make this 30-35 minutes, at max a 40-minute session, in which after that, in last session, we couldn't take out last questions. So in case if we extend also, we'll try to spend some time on the Q&A sessions today. So very briefly about our company, the company was registered in Poland in 1994. I registered this as a joint venture in India in the year 2013. So this is now 12 years after we started the company in India, but my association with the company is now over 15 years. By 2025, we have opened our office in India, in Middle East. So now we are covering the larger territories We've also expanded our customer portfolios, distributor portfolios. So the things are getting in shape after this many years. Some of our global customers, and specifically for the Indian audience or the customer base in India, we have most of the power utilities, or I can say almost all of the power utilities in India is our customers. And we also have expanded our base into railway, oil and gas, navy, sometimes even into the police forces, airport authorities. Yeah, so we have a wide set of customers, plus the private market customers. The company operates on four different segments. We operate on T&M, we operate on automation, we operate on calibration, and we operate on LV transformers. In T&M, power quality is one of a topic of T&M division. We operate on transmission, distribution, as well as in the final customers. In these are the set of products, almost about 200 SKUs are available in testing and measuring equipment. In T&M, we will today focus on PQ analyzers and the solutions of PQ. For automation, we work again a wide range on automation products. One of an automation product which is connected to PQ is the disturbance recorders, which I've highlighted also. I'll explain to you in detail about the disturbance recorders. We also work on the calibrators for the energy meter calibrators. And recently we have created a joint venture with a company from Germany. The MBS is a leading CT manufacturer in the globe. So we have now started a company in Germany with the MBS as MBS Sonel. So because of that, the CT baskets are, because of this joint venture, we have now started promoting the CTs in India. So this is the total 4 baskets which Sonel India is handling in India currently. And today we'll focus more about power quality, as I told you, a bit deeper about power quality. Uh, but before I start with power quality, I wanted to share you some scenarios what I think about power quality, because let's keep the definitions and the standards for a second. And if we address the market, what we see in India today is, as we all agree, there is a huge power demand that is happening in the country. Once when there is a huge power demand, it is actually the right of the customer to also demand the quality of power. Why I'm using this word? Because when I started the Sonal India office, people who are in Chennai would agree, the early 2010 to let's say mid of 2014, 15, we used to have a power cut of almost like 6 to 7 hours a day. From that 6 to 7 hours of power cut, when the regulation came back in 2016, 2017, Tamil Nadu was also one of the prominent state where this PQ deployment happened at scale. So this is a story altogether. How does one market move from power deficient to power quality mitigation so fast? This is something which is fascinating, yeah. And power quality as a topic, I'm exposed to this topic from my electrical studies way back in university in 2010. I used to compare different manufacturers, analyzers as my part-time work at all in the university. That was even a task which I was doing in 2010. Then I joined Sonal. So power quality as a topic is something which was a fascinating topic from quite a few years to me personally. So now regarding the standards and regulations, I just wanted to quickly point out the standard that is in India, because for the most of the Indian audience, we have to first regularize or look into what is the IS standards, then we will look into the IEC standards, for example. So power quality, there is a dedicated power quality standard which we have. And there is a section 20 in National Electrical Code talks briefly about power quality. And a quick note about power quality was also mentioned in 2023 in 18732. Then comes the regulation. So first three will be the standard perspective, then comes the regulation. So in CA regulation now, power quality is mandated for a continuous monitoring. And when we say mandate of a power quality, there shall be strong standards that is backing up whatever we are going to say. So for the recording or measurements, we will have to look into the standard of 61004-30, and the reporting will be in IEEE 519/2022. When we say IEEE, please note the word standard for harmonic control. This is something which is very new in IEEE 519. The word standard itself is applicable in IEEE. So, with the definition of power quality, again, I do not want to define something on my own. I always take the definition from the actual standards, and I'm sharing it along with the page number, what is written in the standard document itself. But we can talk a bit about how the standard is developed with the definitions. Yeah. So when we say PQ is defined as a set of electrical boundaries that allow a piece of equipment to function in its intended manner without a significant loss of performance or life expectancy. So what is the final expectation of this is we expect that the life of the equipment shall be as we expect for the duration of its time, and during the duration of its time it shall not lose the performance. And when we say this is the final agenda we have, the power quality actually sets the boundaries. In IEC it is stated as the characteristics of electricity at a given point of an electrical system evaluated against a set of reference technical parameters, because IEC always wanted to give you in terms of power quality with certain tolerance, certain limits, because as an electrical engineers, you all know I mean, it's impractical to precisely conclude on the quality of power where we can actually set out some tolerance in the quality of power which we receive. So that's actually what IEC wanted to refer to. But in this total power quality, as mentioned in NEC, this shall be categorized into two groups. I think that is very important for me to categorize in the first slide itself, because though the standard remains same, how this is actually taken out by two different group of customers are something which we have to carefully look into it. So addressing the standard of power quality at a grid level and the factors that affect the power quality at the user level. So both play a huge role in maintaining the power quality, the standards on power quality. So now immediately after the standard, I wanted to show you the regulation. So one is a standard. In the regulatory standards, in the top of a pyramid, you will always find above the standard, is it regulated by the authorities? So if you look into the CA safety guidelines, CA guideline for the distribution energy sources, you will find fascinating points about power quality. Let's first look into point number 5. Point number 5, which talks about the measuring and the metering of harmonics shall be a continuous process with power quality meters complying to IEC 61004-30. It shall be a continuous process and the equipment shall have some necessary standards that is backing up. Why the standards? I will share you in the next slides about why this class A is mentioned and what is the significance of it. Yeah. Then comes point number 4. The limit of injection of the current harmonics at the point of common coupling by the user, method of harmonic measurements, and other such matters shall be in accordance with IEEE 519/2014 standards as amended from time to time. Now the standard is amended to 2022, so naturally this regulation have to be followed up for up to IEEE 519/2022 standards. So who are this applicable to? The applicant seeking a connectivity of 11 kV or above shall install power quality meters. So basically the bulk consumers from this definition point of view, because way back in the definitions also it was rather than a kV rating, it was used a term called bulk consumers. Point number 8. In addition to harmonics, periodic measurements of other parameters like voltage sag, swell, flicker, disruption shall be done by the distribution licensee as per the IEC standard. So this is the voltage quality is always a concern of the utility company, and this can only be achieved when the current harmonics at the PCC level is controlled by the customers or maintained by the customer. Only then the voltage quality shall be, delivered by the distribution companies. Yeah. So the quality of power specifically related to voltage quality or anything related to the supply of voltage is always the primary concern of the distribution licensee here. Now, some of the common power quality issues. I'll bring couple of important, though the definitions, there are a lot of inclusions in power quality. Let me pick out some handful definitions which is important for the larger context. What are our major concern is about the sag, swell, and unbalance. So coming back with the definition, IEC will always define it with a tolerance. So the sag defines the tolerance with certain percentage. So there can be a temporary reduction on a voltage magnitude at a point in electrical system below threshold. So how do they define what is the threshold level is 10% to 90% of the nominal value, lasting up to 0.5 cycle to 1 minute. If it goes beyond this, according to the reference, it is higher, so it is considered as a sag. We call it as an event. So how many events are being recorded as voltage sag? How does it impact the customer? That is a secondary point. Voltage swell, again, the same with a tolerance. Here, the temporary increase of a voltage magnitude at a point in an electrical system above a threshold. And what is a threshold? Which is more than 10%. So if it is falling, we can put it in this way. So if there is a dip, you call it as a voltage dip, and if it is increasing, we call it as a voltage swell. Voltage unbalance, very common phenomenon these days. Most of the customers does face this problem on voltage unbalance. In a polyphase system where the RMS value of the voltage and the phase angles between the consecutive line voltages are not equal, even a small voltage unbalance can induce large current unbalance in the motors, leading to overheating and permanent failure. Very common phenomenon. And when we look into the office premises or from the industrial customer's point of view, this flickers also plays a quite an important role. So the flickers are further classified into short-time flickers or a long-time flickers. That is the, let's say, the flickering part or the rapid voltage fluctuations which is happening. Then, commercially speaking, two important topics. When we say, when I want to deploy or when we want to discuss power quality, it only makes sense when there is a commercial benefit to the customer. So today, from the commercial benefit to the customer point of view, let's say from the tariff point of view also, there are two topics which will be covered. Yeah, one is harmonics, second is power factor. Every utility tariff across India will be only based on these two structures today, specifically on the demand charges, power quality rebate, power factor rebate, or your harmonic distortion. This is how most of the utilities tariffs are currently in place or under development. We can pick out many state utilities. The regulatory authorities are defining their regulatory conditions in power quality as well. And we can name quite a few states which have already released their regulatory compliance as well. So coming to the definitions on harmonic, this is actually from the regulatory perspective quite an important title or the disturbance. So harmonic distortion, we will talk very deeply about the harmonics in the next slide. So from the definition point of view, it is a deviation from the voltage or current waveform from a sine wave due to nonlinear loads. As we all know, the nonlinear loads generate harmonics. I will not even use this word generate. It is inducing this harmonics wave back to the grid. And this is something which is very, very a concern for the customer as well. When we say standard regulation, please note this very, very importantly. Why? Because there will not be a regulation unless and until it benefits or it is troubling every people in the platform. For example, unless and until a customer has benefit of uh, working out on the harmonic elimination, the customer will never wanted to discuss about the harmonics. So customer will have a harmonic problem, and the customer, by eliminating harmonics from their operations, will be also benefited. The same thing applies to the utility also. So from everyone who is involved in this cluster shall be benefited, and it is a matter of concern. Only then the word of regulation will be coming into picture. So customer is also the equal beneficiary on attending the power quality issues. Surge, the transient surges are also something which is very common these days. I find three common discussions with the customers. One is a surge, which is a rapid increase in the voltage or current in harmonic issues or the unbalance issues. Quite three common factors which is troubling the customers these days in most of the discussions. Then comes what is a definition before and what is a definition now. So for example, even now this is applicable, but from the regulatory perspective, the definition is slightly modified for TDD. So from total harmonic distortion point of view, this was the regulation which was in place, which was the regulatory requirements that is applied by the customers as well. So this is the ratio of root mean square of a harmonic content divided by the percentage of the fundamental. So this was actually the methodology on how the harmonics were measured and the solutions were also designed for. What changed in the recent regulation is from THD, it is modified to TDD. Now, what is a major difference here is the numerator remains the same, but the denominator has a small change, but a very significant change, a percentage of maximum demand load current. So from the previous definition, what is only changing is to the percentage of maximum demand load current. Let me give you some of the instances why this is significant. So way back when we go for now in 2025, this makes a lot of sense. But way back in 2017, 18 and all, when we did PQ audits, we used to make this THD analysis. And we used to, the first three steps which we always ask the customer are, for example, we'll collect the electricity bill or the consumption from the customers for the past as much as months we could take it from the customer. We will analyze the maximum demand consumption by the customer. How does the tariff actually works inside the customer? So we get some idea what is the actual demand which is running inside the facility. And before any we start, I mean, I personally wanted to start a PQ audit. I will always want to insist the customer, please start the company or the operations to the maximum that you can do. Because if you take a PQ audit while you were having a average load which is not very significant, yeah, the harmonic distortion which is running inside the facility were very, very higher. So we usually were insisting way back in the older days also, we were insisting the customer, please give the maximum current. Why this is important? My numerator remains the same. So what was my agenda way back then also? I have to push my I1 value equal to IL value. Though this was not actually our agenda, but we were actually requesting the customers to give it for the maximum load current. Please note, if you will bring I1 to IL, I mean I1 and IL almost in the similar value, you're going to have a total THD or a TTD similar. But if you will evaluate only based on the fundamental current, you're going to have a completely different waveform altogether. This is something which is very significant for the users. More than the utility, this is actually something that is emphasizing or helping the users. Maybe you don't have to work out for the entire fundamental value at every instance, but at least we can work out for the maximum value of your IL, which will largely benefit the harmonic measurements at the PCC level. The other important commercial factor is power factor. Though we know the ratio, when you address a power quality, you actually have an indirect benefit by improving the power factor and also having a possibility on energy savings. Yeah, energy savings. So the definitions are very clear. That is a ratio of a useful power, active power to the apparent power. We know that. But what is actually interesting is the second highlight. The states, there are some states where we have a kWh billing, and there are some states in India where we have a kVh billing. Yeah? So in the states where there is a kVA demand plus kVh billing, improvement in power factor shall affect the savings in electricity bill. Always, that is also known to the customers. So, but how do we address this improvement of power factor, which I will explain not only from an APFC panel, but when you work on a power quality issues, how does that improve your PF, and how it can bring in electricity savings are also something that we could consider. Then when you start the measurements, when I wanted to do some audits, the testing equipments actually plays a significant role in this topic. It's not like any other electrical testing equipment. This is a very significant tool or a device which is going to be, let's say, in a legal perspective also very important. So there are two definitions. There is one more definition, class B, but it is almost going to be ruled out. So currently the two major products which is running or used by the customer is class A and class S. In class A, we have a precise measurement, and the class S is for the statistical application. So from the user perspective, wherever you wanted to talk to a legal authority, for example, a customer is in discussion with a public utility, it is class A. When it is only an industrial manager, he wanted to make a statistical application survey within their premises, usually it is class yes. So the processing speed within class yes, from our point of view, from an equipment point of view, the processing power inside a class yes will be significantly smaller compared to a class A equipment. That is, from the commercial perspective, also class A are significantly expensive products compared to class yes. So now from this, if we wanted to move to the standards to IEEE, there are a couple of changes on IEEE 519 standard itself. The first changes I will say is the title itself is changed into standard IEEE standard for harmonic control. From our point of view, I mean, from our point of view, from Indian regulatory point of view, or from the standardizing body point of view, we usually take a reference from IEC standards. We do not take always from an IEEE standard, and we call it as a standard also. But as I showed in the first slide, and now this is actually approved or written in the regulatory authorities as well. So this standard, it's no more a recommendation, it is a standard that we have to follow as per the regulatory authorities. The second important part is uh, where does this standard actually apply? This standard specifically applies at the point of common coupling. We usually call it as PCC. Now, this PCC point is where the limits, the regulatory authorities' conditions are always, always addressed towards. Why this is, I'm emphasizing on this point is also because when we discussed the power quality in the previous sessions, though there are standards, I mean, there are standards for how do you mitigate power quality or a power quality issue within the customer premises is one part, but more than that, it is also significantly important to see it at a larger perspective. Why? We know nonlinear loads are a primary source of harmonic issues. So, but we can't throw it out. No, this is a part of our design. This is a part of our consumption. This is a part of our plan. This is a part of our strategy towards energy savings. I mean, the electricity and the EB bill savings. So there is a lot of reasons behind how the design is also prepared for the customer. So it is important to address the regulation from a larger scale. So that is why PCC is the only point of measurement, or we will have to want to look into the power quality issue from the regulatory perspective is from the point of PCC. And harmonic control is no more a THD, and it is moved to TDD as explained in the previous slides. So I already mentioned this is a standard that shall be applied at interface points between system operators or owners, which is usually the distribution licensee, and the users in the power system. Yeah. So there is how these two parties can actually talk to each other on the quality of power that is being delivered to them. The limits in the standard represent a shared responsibility. That's something which is very important, because I will give two, three examples when we did this power quality audits before these regulations came in. I don't know some instances where the customer even had a say. The customer had only one requirement from the public utilities, where the previous definitions were THD. So in THD it shall be maintained at 8%, voltage harmonics at 5%, and individual at 3%. And there was no shared responsibility. It was really like the utility used to emphasize you have to maintain it at this. This is the standard. I will even show you some of the tariff statements from the utilities before. So this was like that before. Now this is a definition clearly draws a line. This is the responsibility of the utility company, and this is the responsibility of the users. So the users produce harmonic currents, clear. The utility is not actually the primary source of it. Usually it is always the customer who has a harmonic current that flows through the system operators or operator system, which leads to voltage harmonics in the voltage supplied to the users, which means I am running a company, and let's say I do not have a power quality issue within my facility. Because of a current harmonic that can be coming from another facility would actually impact my incoming supply. So utility is at a legal scale responsible to ensure, though I didn't create any power quality issue, I'm supposed to have proper voltage supply given by the customers. So this is something which is very significant from the utility point of view to ensure the proper power supply is delivered to all customers. Let me give you an example. Let's say I'm a metro water supplying company. If I will pollute the water, and my neighbor have to take the same polluted water, it's not ethical, it's not right. So the water company shall say, boss, you're not allowed to create impurities in my supply. The same applies here for the electricity companies as well, because The scale of problems that is created by the customers in some customer premises are at a larger scale. I've seen a couple of instances where, at no mistake of the from their company, because of the neighboring companies, some of the customers had PQ issues in the past. Uh, Moving forward, though we have explained the nonlinear load changes in sinusoidal nature in the AC power current, thereby resulting in the flow of harmonic currents. These harmonic currents also lead in increased losses, heating in numerous electromagnetic waves. These nonlinear devices are a key element of energy saving. So it's impossible for us to remove this from the system. But how robust can we create the system even with few agendas? The main agenda is, of course, I need to have a savings on my electricity bill, and I need to create a grid which is robust. Robust is from the standard perspective, is it a weak grid or it is a strong grid? And another important part is for IBR solutions, the inverter-based, which is, for example, in solar applications or where there is inverter-based resources, IEEE 519 states in such a way that you will have to move for a standard of IEEE 2800, where there is a significant difference between IEEE 519 and IEEE 2800. This is one of a sample of an IEEE 519 report. This is it's quite a large report. It has about almost 30-40 pages when we print it out. I just wanted to show you a sample of how an IEEE 519 report will be generated. And more towards an this IEEE 519 standards. Let me quickly show, because from the old standard, now what is the difference now? The old standard clearly talked about THD. It was only one defined. THD on my current shall be less than 8%. THD on my voltage shall be at 5%. Even though THD V has significantly no influence by the customer, it was at PCC, the THD V shall also be maintained, and the individual harmonic component shall also be maintained. Now, what is the major difference here is, you see, the maybe the total essence of this presentation is can be concluded from this one slide. The current distortion limits for the system rated between 120 volt to 69 volt. This is the total distortion limit for up to 69 kV, which means almost 95% of the market will be covered in this one particular kV rating from the list of customers point of view. So from what is the definition? From I showed in the beginning, for TDD calculation we use IL, so that the same IL is taken here also. And what is it? Another parameter which is shown here is, I even marked it in red, this ISC by IL. ISC, as shown in the definition, is the maximum short circuit current at PCC. But let me put to you very frankly, none of my customers or a majority of the customers do not know what is this ISC value. This is actually to be conveyed by the utility across India. If you will ask any customer, do you know what is your ISC value? Mostly they do not know. They always have to go back and check with the utility. And the only IL value, that is also something that you record it over a period of time, which is also not available with many of our customers. So this ISC by IL value shall be important. And we derive what is the ISC by IL value. Let's say your ISC by IL value is somewhere between 20 to 50. Then your total TDD allowed limit is 8. And what is that? Please read on the left hand side. The 99th percentile, very short time, the harmonic current shall be less than 2 times of the values. It's actually the 99th percentile, not the percentage of the value. It's a percentile value. Percentile value means, let's say I'm doing a recording for a week. Approximately 3-second data will be what? 27,000 approximately. In that, the percentile of 99th percentile shall be below this particular value. The same is applicable for the daily data and also applicable for the weekly data. And why do we do the two definitions on daily and the weekly? The same thing will be reported in the reporting format as well. So why do we wanted to analyze? We wanted to analyze both the short-term analysis as well as the averaging period analysis as well. So from a weekly perspective, on a 10-minute averaging period, on my 99th percentile, how does my total TDD work? So that is something that is defined very clearly in standard. Now, from my old experience point of view, getting the limits on ITHD below 8% before this regulation came was a challenging task to the customers. But with this changes on the definition, I will not say this is challenging anymore. This is very well possible by the customers to get it implemented in the within their premises. So for the customers who are having a, system rated voltage more than 69 kV to 161 kV, you will see that the TDD value is slightly getting reduced here, but that's how actually the system also will work. Whenever we did the PQ audits before the standard again, whenever we did a PQ audits for the large bulk consumers, I mean the huge manufacturing facilities, they were not actually having the harmonics on the at the PCC level, because the impedance of their system were much more higher because of their higher rated transformers incoming. So things were quite sophisticated even for them way back then. Then also the voltage distortion limit, but this voltage distortion limit is usually, it cannot be done by the customer. It is usually for the utility company, yeah? Because if the customer can work out only on the current harmonic issues. They can never work out on the voltage distortion limits. So for the voltage distortion limit, the THD percentage is also defined on the percentile value, that is daily percentile value and the weekly percentile value. Now, I gave in the beginning of my presentation about Class A and Class S analysis. Now, why this is very important is because all these reports, all these definitions, all this shall be done, but not only from us, from any company today who has a 61004-30 edition 3 certificate with an IEEE 519 2022 implemented in their products. You will be able to do this with after the recording. You will be able to take out the data with few clicks. Not necessarily that's the total agenda. Yeah, this reporting shall not always be done by a PQ expert. Not necessarily. In many instances, when we wanted to take this at a scale, only when the people who do not know the standard also shall be able to take out the report, shall also be able to work out on the limits, is only when the report is actually able to classify it as events. So when you take out the reports, how many times you have the limits exceeded will be clearly shown in the IEEE 519 reports. Now, from the utility perspective or from the end user perspective, the definitions, PQ definitions remain same, standard remains same. But what actually differs from the two people is the data. How do you actually take the data? The utilities usually go for a fixed or a panel mounted, where the end user will go for a semi or a portable devices. And usually utilities used to ask us for the integration with the central PQDMS file for analytics and the regulatory reporting. And end users will demand a software so that they can prepare a report. And utilities will always look out for one more file format, is the PQDIF format, where they're able to integrate into the SCADA integration. But please note, the data which is captured by the equipment always remains the same. How do you transfer the data, and what is the extension file of your data? How do you read the data? How do you put a watchdog function behind the data? Those are the functions which is changing, which is actually evolving very, very rapidly. But the fundamentals, what I told you until this moment on power quality, why the power quality remains, is going to be same, I mean, even for the next years to come. And utility also has requirements again primarily on how do you work on what are the type of a network that usually utility has. But here, from the end user perspective, there are sophisticated requirements from the end users on all possible combinations. Again, on the data and the SCADA automation is where power utilities do actually work. I'll also show a couple of solutions what we are working on. We work on the utility perspective, panel mounted perspective, and also from the end user perspective. All three different perspectives we work on. This is our recent changes on the PQ device. We moved from a portable device. I mean, we still have a portable device, but we have improved our devices from portable devices to a permanently fixed device. Why this is important to have a permanently fixed device is because the regulation was emphasizing on continuous monitoring, and there is no need of a software to be used, I mean, to be required by the users. So the definition on regulation says it must be permanently installed and it must be picked up by the authorities or the clients at any instance. It must be continuous. So that is a primary reason for us to bring out with such kind of a solution. It is Class A certified by Meta Switzerland. And this is also something that though I don't want to say this as an issue, but we find even non-standard practices or non-standard equipments could actually create the total recording disturbed. So it is important that we address this with a proper certificate, because this is going to be a legal document. For example, if you say my TDD is beyond the percentile value as mentioned in IEEE 519, and you wanted to take this discussion with the utility, unless and until there is a certified equipment, this cannot be taken out, because an equipment can take out any data. For example, if you see from the hardware perspective, we are having only the voltage and the current input in any analyzer. There will be only voltage and current inputs. Every other parameter is actually mathematically calculated, mathematically generated. So unless and until we have a proper certifications behind it, this cannot be emphasized legally. So just to give you some quick updates about the hardware perspective, the necessary voltage and current inputs with all power quality parameters. When we say all power quality parameters, though I have mentioned couple of instances or examples before in my presentation, any power analyzer today will be able to give you all this data. The only question a customer should ask is, do you have a certificate? The second question a customer should ask is, based on your requirement, how do you want the data to be on your disk? We moved from, as I told you, we moved from the software point of view to a web server login with a robust, secure web server login. So you are able to monitor this at any instance. The utility can monitor at any instance. The customer can monitor at any instance. There is a watchdog functionality. So people are able to take this PQ or a PQ deployment at scale. You can take a measurement at real time, you have a waveform at real time, and this is also something which is very interesting, because as I told you, the events, you can actually pull out all these events in a single click, and you can take out the data in the graphical format, PQDIF format, and naturally in any particular format that is required. Now, there is also one more instances from the utility point of view. The utility do not want permanently fixed analyzers, as I showed before. The utility wants disturbance recorder. These are, from my point of view, a bit more sophisticated recorders, where again the definitions of power quality will remain the same, but where we are actually working out is how do you again take out the data. What is the primary concern of the customer here? I mean, both of these are certified Class A equipments. It can generate IEEE 519, but the data formats, how this is being sent, is completely different. So we take this data from different bays, bay 1, bay 2, bay 3, we bring it over a switch, and then we are able to continuously monitor the power quality parameters. So this is one methodology, and another methodology of doing it. We are taking this in, there are also utilities which is requiring this in the format of COMTRADE or PQDIF files, and it is transferred by the means of Ethernet, RS or GPRS requirements. And regarding any other parameters, once when I say it is a certified Class A equipment, your GPS clock synchronization or PRP for redundancy, everything's are taken control. We have also emphasized or sophisticated this total deployment in how do I take multiple analysis. For example, 2 measurement points can be taken into one device itself, and I can transfer the data from one device. And another form of a device, this is used by the customers actually for quite many years. These are portable devices, but again, the PQ definitions will remain the same. How do you take the data here? Here it can be from an LTE format. For example, you can insert an LTE SIM and you can do the data transfers. This can be taken into a portable version or also on the permanently fixed versions. But all other parameters on 61004-30 and IEEE 519 will remain the same. The reason for me to show these three different perspective of equipment is how, because this is demanded from the customer completely differently. Utilities will demand completely differently. An auditor will demand completely differently. The user who is going to deploy power quality or attend the power quality issue is going to have a requirement in a different way. Now, when we have a grid which is having we are moving from supplier to consumer, this is prosumer. How do I take the data? How do I synchronize the data? How do I take the data from multi points? This is how we are actually moving towards the PQ fundamentals is always remaining the same. So what are we now working on as multimeter multi PQ devices integrated in multiple locations, and we're able to take the data from the different customers. Now, once when I take the data, until now I told about the collection of power quality parameters. Now, the moment you collect the data into with you, the next immediate question is, okay, what am I supposed to do with the data? I have collected the data in any requirements. I'm from the utility, I'm from the customers. So now I have a data. I identified some of the problems. Now, how do I address this power quality problems? This is also something which is very fascinating. This I've taken it from the National Electrical Code section 27.1. So let's see from the three steps on how do they address from National Electrical Code point of view, how do they address this PQ issue. So as we know, there is a nonlinear load and you have a supply network. So the harmonic current that is caused by the nonlinear load connected to the distribution system flowing through the system impedance distorts the supply voltage, as I told you until this moment. Such loads are increasingly used in all industrial, commercial, and residential installation, and their percentage of load is growing steadily. Now, this is the problem what we have. Now, what is the solution that they go for an automatic power factor correction, which is our APFC panels, is with let's say three steps. We will explain it. The capacitors are sensitive to harmonic components of supply voltage due to the fact capacitive reactance decreases as the frequency increases, as we know. It means that a change in a relatively small percentage of harmonic voltage can cause a significant current to flow in the capacitor circuit. So there is only by using a capacitor panel, we will not be able to achieve what we wanted to achieve. So there is a small correction to it, which is adding a reactor to the capacitor bank. Market know this product, and I have even seen this installed in many customer premises, called as passive filters or detuned filters. So the reactors or capacitors are configured in a series resonance circuit tuned so that the series resonance frequency is below the lowest harmonic frequency present in the system. The use of the detuned reactors thus prevents harmonic resonance problems, avoid risk of overloading capacitors, and thus reduce voltage harmonic distortion in the network. So these systems were also available. But according to NEC 23, regarding the effect of harmonics, what I've highlighted here is in comparison to all of these solutions, among these, active harmonic filter offers a flexible, scalable solutions on harmonic mitigation. AHF sends the current by means of CTs mounted on the mains load. It calculates the harmonic current requirement of a load and produce a harmonic current which will be in phase opposition, which means it will identify a harmonic current and it is going to pump in the negative harmonic current, so it can actually nullify the harmonics within the premises. This way, it will reduce the harmonic current drawn from the utility. Before this 3DD happened, this is one of the tariff sheet of it, for example, TNEB. What was available in TNEB in 2017-18 was one, there was a penalty for a power factor. And they also had this is not the current tariff, please note. This was an older tariff which was applicable. The customers had a liability to pay 15% of the respective tariff. 15%. Let's say someone is paying 1 crore as an electricity bill, they ended up paying 1 crore 15 lakh rupees as an electricity bill, just because you haven't exceeded harmonic limit. And previously it was classified into HT1 and H3 customers. But as I showed you in the previous definitions, IEEE 519 have classified up to certain rating of customers in the harmonic TDD calculation, and beyond 69 kV it is also calculated into the classifications. So to mitigate it, there is the requirement of passive and as well as the active harmonic filters. This is the total cloud of power quality. What I mean by total cloud of power quality is, one, you measure the power quality. Second, you mitigate the power quality. In mitigation of power quality, you will be working out on the passive and as well as the active. Though the standard recommends the active harmonic filter at scale, from my experience, though this is a debatable point, some agreed with me, some do not agree with me. I personally wanted to have a drawn line between an passive and an active filter at the same instances. I've seen why, because yeah, active filter is scalable. Active filter it's a very good system, no doubt about that. But the cost of maintenance of a solution for a period of time, for example, if I will take the ownership of a filter for a period of 5 years, and if I say from having a passive plus active, the cost of again, it all comes down to what is the right optimal cost. From that perspective, I personally will I'm recommending to the customer to find a balance between active and a passive. So people used to call this terms as hybrid in some instances, and this ideality between an active and passive is where we will actually mitigate the harmonics instance. So one, we identify the harmonic problems or any form of a power quality problem within the customer premises. Once when you identify, you can actually work out as on the harmonics, because from the commercial perspective today, from the tariff perspective, it is only your demand charges, power factor, and harmonics. I'll also give you one example, but this example is done not a TDD, but from the THD perspective. It will explain what I mean by that also. Well, this is a textile company where we did a PQ audit. There was one transformer. The sanctioned demand was 450 kVA. The capacitors what they had was 230 kVAR. So they had a line incoming at 430 volt, and the current is at 364, and the THD percentage was about 30.92. So again, when you go into the customer premises, when you do an analysis within the customer premises, it's always THD. And the power factor at the customer premise was about 0.94. So here the customer went out for a 100 ampere active harmonic filter with a 230 kVR, the complete 230 kVR on detune filters. I've shown it on THD intentionally because this THD, the customers worked out on THD, but if it's also an interesting question, but you mentioned THD that is on the fundamental current, not at the maximum load current. True, because when you address this problem at a fundamental current, the difference between the fundamental current and the load current could be significantly higher. But again, as I told you, this was done before the 2022 regulation came in, point number one. And point number two, even today, when we wanted to design a solution inside the customer premises, we wanted to look into the factor of THD also. I don't want to neglect the factor of THD, but I will want to address this with THD. But we always wanted to look into it from the compliance point of view. Yes, the TDD, bringing down the TDD at a percentile level is also essential. Now, in the beginning, I mentioned about the power factor. The definition on power factor. An improvement on power factor actually improves in the electricity savings. It is true because when you do the power factor improvements from also from balancing out from an active harmonic filter point of view, because here you're improving the power factor, not the right word as I highlighted is in the real time. The adjust compensation according to the load variation happens much more quickly than our old systems. If we do that, the power factor improvement happens much quicker. So we are able to maintain the power factor also And in a KVH billing state, not in KWH, but in KVH billing states, we could actually identify the electricity savings as well. Before I wanted to end out my session, I wanted to quickly introduce to share some of the case studies from Indian Railways. I wanted to invite Mr. Hari Krishnan, who is a senior section engineer from Mumbai Railway. Mr. Hari Krishnan, are you on the line?
Yes, yes, I'm available.
Yeah,
Am
Mr.
I
Hari,
audible?
yeah, you're very much audible, sir. So,
Yeah.
Mr. Hari Krishnan is working on this power quality for quite some years, 8 years in a row, and he wanted to share some of his experience because more than from Sonal perspective, it is important to address this from the customer perspective. Yes, Mr. Hari Krishnan, I've added your comments in the next slide, please.
Yeah. So, from a user kind of perspective from railways, so I've been working with railways for the past 7 years. I am a section engineer who looks after basically SCADA as well as the relay system here in railways. So, for quality meter we have been using this PPM 702 in our various installations for a long time. And even before me coming into railways, it was used here. So I'll just give my like my user experiences with the same thing. So apart from usual power quality measurements which we have to do in our installations in our 110 kV substations, this PQM power quality meter has been a very helpful thing for our all kind of our fault findings and any issues which we face in our usual systems. For example, we can say that like we have a single phase transformers which we use for traction distribution. So from an uh, like for a perspective view, we have like single phase differential series strippings which we have faced in our system. So from the power quality meter, we can get the data, current data for even the half cycle level. So we can closely monitor the current values and we can see the differential current where it is arising from bad connections, bad contacts, anything kind of such use cases can be done with the PPM also with the usual power quality measurements. So this PPM it gives a half cycle data, so it's very easy to analyze the data, and the this PPM software has a funnel analysis software. It's very user friendly, which gives us a wide range of applications such as like any monitoring of values like voltages, current, power in our systems, along with the three-phase power quadrant, four-quadrant power and load characteristics. Apart from this, we usually use this for the harmonics in our system, as well as like verifying the relay data because it's a class A equipment where we can actually kind of like verify our relay performance and parameters. And it's been very useful for us in the past, 10 years, which we have been using this thing for. And the support from the Sonel is also like MS Sonel is very supportive, and they give us like any if there are any queries, like if we have any doubts, they give us instant support, and everything is available on a call from Sonal instruments. Thank you, Mr. Shyam, for giving me this opportunity to share my experiences with you and all the people who is in this webinar. I hope this is like, and over to you, Mr. Shyam.
Thank you, Mr. Hari. Just one more quick question, sir, out of a curiosity. Were you
Yeah,
able to identify, when you mentioned the all the use cases of power quality, thank you
yeah,
so
yeah,
much for that. But were
yeah.
you able to identify some faults and you were able to mitigate because of that some benefits happened out of it? We are always curious about
Yes,
how
yes, yes,
it was
yes.
useful in inside.
Basically, you have a single, for example, in the zonal like PPM thing, then we can connect this particular equipment in a single phase with neutral measurement method, right?
Mm-hmm.
So
Mm-hmm.
we
Mm-hmm.
can monitor both phase and neutral current at the same time.
Mm-hmm. Mm-hmm. Mm-hmm.
So
Oh, okay.
in a
Okay.
particular case where we had differential tripping in our transformer, so it is basically due to some bad connections in our secondary side, which we
Mm-hmm.
couldn't identify in the long control cable this thing. So we monitored this particular. This happened once in a while in a month or something, and we couldn't
Mm-hmm.
basically identify because Mumbai is a place prone with all rodents and these animals. So squirrels can damage the cables. These things can just cause any issue. So We were like basically like looking around like everywhere to find out this particular fault, why it is happening, why there is different transformer tripping. And differential tripping is a very serious tripping, and we can't just charge a transformer just on our intuition. So we need to identify what caused the tripping, and it became a very big issue for us. So we started basically monitoring the neutral and phase current in the secondary, which causes the differential tripping. And we observed like in between we are observing like a sudden spur, like surge in current, or like some drop in current values in the two different like phase and neutral. And this basically caused the differential relay to trip. And then we started like identifying like what is this cause, what is this like basic source of this thing. And when we check the whole control wiring, we could identify that like the basic wiring had a small like issue where the current had a leakage, and this caused the spurious tripping. So this is from a point of view of the differential tripping. Other than that, we have this breakers, right? Like this can cause like breakers over the time, can vacuum breakers can, it can cause like the vacuum to be not there and cause partial discharges in the VCBs. So we continuously monitor, like in case if there is a like issue of like voltage in the line, whenever, even when the breaker is open, we continuously monitor the PT voltage in seconds, milliseconds, or half cycles. And if there is any slight voltage recording in our PQM data, we can identify this as like, okay, then there is a partial discharge happening, and we immediately test the equipment and then, replace it, or we take the necessary next step in the uh, cases. And other than that, like we monitor the loads and other stuff basically in our system. And other than that, then PKM is extensively used for like in tracking purposes. The in traction system there is like a lot of lines here in Mumbai, and to monitor the potential differences in between the lines if there is a crossing there. And recently there have been instances where like the train's pantograph kind of bridge to overlaps and causing some this wire parting and all. So we have a study case where we were observing the potential differences in between two lines, and whether these potential differences are like enough to cause the current to flow from one section to another section. And such use cases have been like, we have been using it in on our own, like we have been improving, like for example, the power quality meter to be in our own method to utilize the power quality meter for our own purposes, like that.
Okay. Thank you so
Yeah.
much. Thank you for sharing this information. As you have mentioned, this is in use for almost 10 years. So we are also very curious to know about how this is deployed in the customer premises. At
Yes,
the
yes.
end of the day, your use case scenario is where, though we tell all the definitions, but how you modify this product usage actually, to be frank, fascinates us. And
Yes.
that's where we go and rework the product and bring, okay, this is the requirement of the customer. There is one that is standard, which is the minimal base we all achieve on. The second is all the use cases. So thank you so much for sharing this. I'm actually fascinated when you told from power quality you moved to partial discharge. So that is something which was I was not expecting it.
Yeah, but this equipment, like it gives a very like the half scale readings are very much like we have very less instruments where we can read this half cycle reading from any other, from the
Sure,
system. Our
sure,
SCADA and
sure.
all, they log the data in a very huge, like SCADA can basically log the data in that value. So we need something
Understood.
local where we can, store the data in a such huge amounts, and we can analyze the data. That is very important. There can be
Sure,
data everywhere, but analyzing the data is very important. The software which we use to analyze the data, which Sonel analysis, is actually very user friendly. So
sure,
it
sure,
gives us a like very easy to use the software. That's a very huge advantage for us.
sure, sure. Thank you so much, sir. Thank you so
Yeah,
much for
thank you.
your time and experience. I will connect
Yeah,
back with you regarding to know about this partial discharge a bit more. This is fascinating. Thank you so much for your time, sir.
yeah, sure, sure. Thank
Thank you. So by this, we will end the officially on the presentations. We can take out the questions. And this is the contact detail of me. If you have any questions, please always do share your queries, even now or later on. Thank you so much for your time and attention. And let me open out the Q&A box, Dominic sir?
Shyam, it will be good if you can take it up,
Yeah. Where is the Q&A? Should I stop and go for a Q&A?
Up to you. There are around 19 questions here.
Okay. Okay. Yeah. Okay. I will address. I'll try to address. Is IEEE 519 applicable for LT supply? Sir, I mentioned the ratings of the voltage limits. Let me go to that slide specifically. The IEEE 519 limits. Yeah. So it is usually targeting from the regulatory perspective, it is usually targeting the customers from up to 69 kV, but usually it is targeting the distribution. I mean, from the distribution, who takes the distribution license from the customer, from the utility company. It's not for the LT supply. It's not possible to bring such kind of regulations on continuous monitoring in LT supply. Of course, this question is not related to the presentation of topic. Can we have testing and measuring instruments for BS? 100%, sir. We will contact you back. I will note down your details. We will contact you back after the session for your requirements. Class A, Class S mesh device which you have indicated, do they need different type of CT apart from the choice of CT are usually up to the application of the customers. Usually the CT part is designed the way you install the custom, where you install and the type of applications that you have. When we talk about this particular topic, I can also maybe put out a kind of a request, because in many instances when we go for a PQ audit, we do not find the necessary setup for us to do the PQ audit itself, neither from the utility side or from the customer side. Let's say in most of the scenarios. So we will have to always go and find out for where I can connect this power quality analyzer. So that is something that is not regulated. Maybe the regulatory authorities can consider this, that if they wanted to go for a monitoring, if they wanted to go for checking, maybe there is some kind of provisions they can create so that it is always accessible for the customers and the utility company, which is, though it is possible to connect, but it is not a standardized method that is available everywhere across the country. Limits of current and voltage harmonics, I've mentioned it in my presentation. What is the TDD limit on V and high? Is there any correlation between load current and V and ITHD? Of course, there is the complete relation between the load current and I, as I showed you in the formula of THD and TDD. The total difference is between the load current, that is the instantaneous load current, and the maximum load current. We have observed a second order harmonics present in the feeders during harmonic measurement. What is possible root causes of behind it, with the possible identifying even order harmonics, or the solution to even order harmonics is not a very simple phenomenon, to be frank, but maybe I will contact you back to get the SLD of your application, sir. But from my experience, attending on a second order I mean the even order harmonics, the solution to even order harmonics is not that simple. But I'll contact you back after this session. With more and more RE and ESS coming into picture to make grid go greener, even now the power generators could be a source of harmonics with poor power quality. Although the grid code compliance requirement at PCC are supposed to be compliant with 519, and do you observe or across scenario where RE plant and PCS are contributing to power quality and harmonic exceeding? Okay, a very interesting question. When we talk about the renewable power integration, the renewable power integration within the premises already have enough issues from PQ point of view, related to their inverter switching, related to their other power quality issues that they have. When they want to connect it back to the grid, maybe we will take it out as a separate session, IEEE not 519, it is IEEE 2800. You are absolutely right. But when we say it from a larger perspective, sir, from what I mean by the larger perspective, from the regulatory perspective, at least the first step shall be to maintain or improve the PQ at the PCC level. So that is the first step they wanted to take in. Can I improve the PCC level, then move it out into, for example, having a better scenario. I will also add one quick point. Maybe it is very important and it is also asked by the customers. If you will notice my screen, one of the common problems on power quality, as you can see in the screen, is the nuisance tripping. Why I'm highlighting this nuisance tripping here is because from the safety audit point of view, we want this nuisance tripping to happen. But if you do not have the right breakers, if you do not have the right rated breakers, you are going to expect a lot of nuisance tripping, not only because from the safety point of view, but also from the PQ point of view. When I say breakers, I also mean not only from your MCCB, but also your RCDs. This tripping, the rated tripping, the rating of that particular tripping, you are going to have a major impact because of this power quality issue. You take any power quality book in the world, you will find nuisance tripping of the breakers. That is one of a common phenomenon of PQ. Why? Two reasons. Is first, how redundant is our system? That's first question. Second question is, did we really have a right type of a breaker? That is also something in all our previous safety audits, in our previous safety sessions, we were emphasizing on the importance of right rated breakers. Next question, how do I calculate ISC? We cannot, sir. We have to ask the utility company. That's what I mentioned. This ISC, I do not know why it is kept as a secret, but many of the customers do not know. I do not know. We have to ask the utility company, and your distribution company only can answer this particular question. What is your ISC? The important parameter is customer shall know what is their IL, because that is your maximum load current which you have consumed for a period of time. I will show you again. Okay. Again, coming back to the fundamentals, THD and TDD. The only difference here is the denominator is not instantaneous value. The denominator for the new regulation is actually the maximum value. So 100 divided by 10 can be 10, but 100 divided by 50 can be 2. So I have to emphasize always on having the highest denominator value. Most of the customers do not have the data of their IL value, but again, we can find out the IL value, but ISC can be only taken out from the public utility company. Ms. P. Velavan, why PF is becoming poor and poor when and solar is available for consumption with B power? If the problem persists because of the resonant power that is generated at a coupling point, then what is the solution? Why it is and how do we able to get the grid of the issues? Even sometimes the conventional APFCs are not responding in PF's correction and leading to lead issues. Yes, true. SVGs are prominently working fine, correcting and mainly PF at unity. Recently, Trinity Electronics have introduced 4-quadrant APFCR with which what is a resonance problem actually and how it can be defined. Resonance. When we go for a solution, Mr. Velavan, as you very well know, this resonance problem or a problem related to resonance will be done or can be identified at the time of commissioning. You will come to know about all these resonance issues at the time of commissioning. And the ideal scenarios, from my experience point of view, this is not the standard. From my personal experience point of view, it is actually having the ideal line between the passive filter and the active filters. I'm not against any other solutions, or I'm not against or in favor of active, but identifying a right based on the PQ characteristics is right scenario. What I mean is between active and passive, I will call it as hybrid. That is the only way from my personal point of view on addressing on the resonance problem. I've noticed the customers, because of the resonance issues, either there is a tripping issue or there is a tripping issue on the active filter itself. I've seen all these instances. But once when there is a right line drawn between these two instances, your lag and the lead issues have been addressed. Next question. 18732-2023 is mentioned PK applicable slide, but Q1 standard is electrical standard of insulation of building. How this is applicable for power quality? Mr. Sunny, it is one.
Shyam, can you put the last slide with your contact details there in your screen that you have shared?
Sure.
And go to the last slide.
Sure.
Because people are asking your contact details, email ID. Yeah, that's okay.
Yeah. Okay, let me address the question, sir. So here, 18732, it's not a standard. It is 18732 was actually trying to draw the lines on responsibility. Now, what is the responsibility of each person inside within the premises? No, for power quality, you will see it in 12.1 and 12.2. 12.1 talks about the instruments and 12.2 talks about the power quality parameters in 18732. The role of transient measurement and power quality instrument, please elaborate. Very important, sir. Very important. This is something, again, transient on voltage and transient on current. Transient measurement on voltage is, though this is not very significant, but it's possible to measure, but we shall always emphasize on transient current. In our state, as per regulatory DISCOM is appointed nodal agency and DISCOM certified only 2 OEM for installation. Is it okay? Or where we can raise our concern? This is a utility or a regulatory question, sir. From a private limited company, I'm not in a position to straightly answer this particular question, but in any we are all coming under the legal legality of government of India. Now, CA has defined two important standards. What is a measuring standards and what is a reporting standards? So if that is the reason you have also noticed that the data had some formats. Now, where this industry is trying to move towards is why the data, I mentioned the utility or the standard of reporting, where this is actually trying to move is to eliminate the dependency on the companies who are supplying this equipments or who can interpret it. Because if I will be able to take it out in some common format, for example, a PQD format or a Comtrade format, tomorrow I can buy the equipment from any manufacturer and I'm able to take out the data in any format. So if legally speaking, if equipment will have a certification on class A, if they are able to have an IEEE 519 2022 standards, legally speaking, you are not in a position to say no to that particular company. It can be any company. So you have to take it out with the utility companies, or from a private limited company point of view, or legally I'm not in a position to take it out. But CA can be a right authority on any concerns, not only from this power quality concerns. CA is a right nodal office for any of your concerns. In our okay. Does that fixed PQ has a memory or communicable through? Oh, of course, it has a memory. We can do the memory for quite sophisticated period of time. What we mean by sophisticated period is at least for a couple of months, where we are able to store the data within the equipment, and of course, we can take the data anytime that is required. Okay, the nature of, during JS isolator, some switching spark is appearing on EHV cable termination. Is it possible to identify, measure transient voltages with this PQ meter? Yes. When you choose a PQ meter, though beyond standard, please look out for the specification on the transient voltage that will be mentioned by the equipment manufacturers on their data sheet. So if you think that the transient voltage is below certain voltage on what is your expected transient voltages, you can choose any PQ meters that is available in the market. The nature of power factor as determined at the user is found to be leading. Utility is objecting to it. At the power distribution level, will there be any undesirable effects? Yeah, 100%, 100%. Definitely. Do reactors installed at capacitor capacitor safety or to reduce overall harmonic current? Both. It is not only for the safety of the capacitor, but also to eliminate the overall. It is not eliminating the reactors do not eliminate the harmonics from the circuit, but yeah, that's how it is. I think still few more questions are added, I guess so. You mentioned about SCADA. It is a naive question. What is your cloud dashboard is doing more than SCADA? My cloud dashboard doesn't do anything more than SCADA. I am having my cloud dashboard to be able to give out all the data from my cloud dashboard. Customers say, no, I don't want a cloud dashboard. Please bring it everything into my SCADA system. I don't want to use your data or your software or your system. I want to integrate everything into my SCADA. And there the customers are having the possibilities to kind of put their own limits, and they are able to create certain events based on their requirements and their system. So it is only about, again, the definition of power quality is not going to change. How you take the data only is going to change. Does the load impedance affect the PQ? Load variation affects PQ magnitude wise, not considering harmonics. Of course, the load impedance naturally affects the PQ. Can we get the usage of meter to identify the issues mentioned by the railway engineer? Mr. Haja, I will share this detail with you after the session. Usually customers doesn't know the ISC value. If board people doesn't specify, then any alternate knows it. You can do some calculation, but what if it is wrong because of any other parameters that it can influence? It is better to ask the ISC value with the grid. And once when you know your ISC by IL value, you are in much legal possibility also, that is right, because we are identifying the ISC by IL value to be in compliance with the grid. So better ask the grid what is their ISC value. Yeah, we can calculate with some formulas, but I don't want to mislead the discussion. It is better to ask the grid themselves. Do we have any solutions where we can improve PQ instead of transmission and distribution? And as per IEC, there is huge power loss during transmission and distribution. Sorry, in transmission and distribution, power loss elimination is they're not covered in my session today. I'm not an expert on T&D loss elimination. I know some instances on how to record the data, but loss elimination on T&D, I'm not an expert, so I don't want to answer this question, but I can note down. Oh.
Yeah, it is there, Shyam. It will be there on record. Yeah.
Okay. So I will contact the customer, please, after the event. During power quality in any hospital industry, it is very unlikely to say which day it is full. Then how can you take power quality with the existing load? Very good question, sir. We are not. We are going to. What is our primary agenda here is to address the solution of power quality at the maximum load. So, for example, I'm going and visiting a shopping mall. The shopping mall will not have the same instances. Yeah, Saturday and Sunday is their maximum load. Office hours 9 to 5, that is their maximum time. So this the duration on the maximum load actually is applicable to every industry. What is very important is if you try to do any kind of a PQ solution when you're not at a maximum load, it is most of the instance that is misleading, because try having a simple maybe not classy or any other power quality meters, try loading your facility on a 20 or a 30% and identify what is your total harmonic distortion. Now increase your load or the maximum load from your instances to 80-90% of your maximum load current. You see what is your THD within the premises, you will see there is a huge difference. And from the PQ audit perspective and from the commercial perspective, it is important that the customer addresses this problem at the maximum load. It is beneficial to the customer also. Can active filter be used at RE power integration? Basically, you can use active filter anywhere that is possible where you have a requirement on harmonic mitigation, sir. What can be an impact of EV charging on PQ? I think Dominic said this is the next title on EV charging. We will have to we will announce the title itself by the end of the session. Next session is about EV charging. from the audit perspective and also from the PQ perspective. We even collected some of the instances. In the interest of time, I didn't show these graphs, but maybe in the next session we will show the power quality impact in the EV charging stations. But all safety standards, PQ measurements, PQ issues remain same here as well. We have identified some of that, and that we will conduct a separate session. I think that is the next session. We will want to talk specifically on the EV and EV data. So do you have a PQ meter record data of di by dt, dv by dt? Here consider 1 microsecond at what level of amplitude. We go up to half cycle and 200 millisecond data measurements, sir, at the moment. And in some other, we have few models. In some models, we can go for much more higher sampling and much more lesser averaging data as well. So next, as per the state discom, PQ monitoring is mandatory to be kept at PCC. Please throw some info on that. Yes, it is. It is. As I told you, this CA guideline is already published. Now it is up to the state authority, state utility, the state regulatory authorities to mandate PQ monitoring, and the limits on PQ monitoring is already defined by CA as well. So they are going to make this implemented. I know most of the regulatory authorities are already working on it. Many have already released this regulatory standards. It is, I can say, by the next year when we are discussing, maybe after a year or so, we will see at least many states who have implemented this PQ regulation in place, and they will go by, as we know from the previous experience, they will go by customer by customer. From what I mean by customer is their primary loads, where they have majority of the problems, where the maximum consumptions are happening, where the redundancy shall not be at all in the grid. So the grid also will be attending it from their importance point of view. That's how it will be. Is CA regulate the consumer to keep PQ monitoring at PCC? No, CA regulates you to go for continuous monitoring, the standard of the equipment and the standard of the reporting. It is if these two standards will say, if IEEE 519 will say PCC, then you are already on PCC. I'm just reading what is written in the document. CA document will only talk about what is the standard you are going to follow. This standard will say go to PCC. Dominic sir, can we continue the questions or?
Yeah, Shyam, you can continue.
Okay,
No,
we'll try to attend a few more questions. In the recent times, smart metering or prepaid metering were installed at the gate communities with single point 11 kV, where in society to take care of PF. If so, is there any PQ measuring needed for the gate community? Sir, when we talk about gate community, yeah, if they have a 11 kV incoming as a gated community, they will be falling under this. From the utility perspective, it is 11 kV incoming given to this particular customer. Now, there is a huge difference between a smart meter and a power quality meter. A smart meter is a smart meter. It can give you the data. But for example, if I say my TDD is by so and so percent, does it have that much of processing power to calculate it instantaneously? The previous customer asked, I wanted to monitor the percentile data, 1 second data. Does it have that kind of a data? Because your reporting format in IEEE 519 is not available, or it is not legally right to take any decision on meters which is not certified. Yeah, they are also they are intended for some other application. I also use a smart meter. I also use in my requirements a smart meter. But the smart meter, for example, if I have a smart watch, doesn't mean I will not go to the hospital to check my health vitals. Smart is something that is important at that particular instance. But when I wanted to take a commercial decision, you definitely need a standard, sir. You definitely need a standard. Do you recommend to measure noise signal current due to high frequency? Sorry. Do you recommend to measure noise signal current due to high frequency apart from fundamental and harmonic current in highly non-linear environment? Sorry, sir, I don't know what this noise signal means. If you can, maybe I'll, KK Singh, sir, I know you, maybe I'll contact you back after this. I don't know what this noise signal means. What can be a cost-effective solution to replace existing traditional SVC to inject flexible VAR instead of fixed step injection. What is written in the standard only, sir? We will have to go for this active and the passive. Sorry. Heyman, as per EN 50160 and IEEE 51, and harmonic limit is measured up to 26 or 30. Why does hardware give out? No, the hardware says up to, if you see the TDD values, it is not up to 26 or 30, it is moving up to 50th order. That is a recent changes in IEEE 519. Is it advisable to have PQ unit charged directly through the mains than using a single phase power supply? This is a hardware choice of the manufacturer, Preet. So when we say I'm going to, this is also an interesting question, because when I say I wanted to go for a PQ measurements for 1 week, because the standard asks you to go for 1 week with percentile, 1 day with percentile, I will not be in a position to ask, hey, can I have an external power supply charger? So this equipment shall have all the necessary means to power itself. But that is actually the choice of the manufacturer, how they take this application. So it is not something mentioned in the standard. It is how redundant the construction of the hardware is prepared for the application of the customer. It again, standard is only the base of our discussion. Thank you for the support of my last question. Are there any other PQ related sessions? Not really, sir. We have next session which we will talk about the PQ for EV charging stations. And after that, we have an interest to talk about PQ for specifically for the solar. That will be our next requirement. In solar system that in shadow found the lost and lost generation, any such clue and suggestion what can be? That's actually last session was about solar, sir. That is actually the shade evaluation, I guess. So that is the question. You can write to me, but I'll try to answer that. Considering that is a shade evaluation, you will be able to identify from an equipment which will do this IV curve losses. But if I'm not very sure, if you're not very sure about that shadow font, because I'm not very sure about what is shadow font, you can write an email to me. I will answer to your questions, sir. The email is as you see on the screen. So thank you so much for your all of your time. Dominic, sir, I will stop my screen. Once
Yeah,
again,
Shyam, thank you. It's been a very productive session. I think, a lot of questions coming in. I think it'll be good if we can have a part 2 also in this, from the looks of it.
I guess so, because I was answering questions for like first 40 minutes or so.
Correct.
So
Yes. I think the audience have a lot more questions coming in, I guess.
yeah.
So I think it's been a very good session. Thank you, Shyam, for taking your time out for this. We also have the recording of this going to be uploaded on YouTube very soon. And I also thank the audience for being very patient throughout the question sessions as well. We have an audience of 193 today, so it's a very engaging audience as well. So our upcoming session on October 17th will, I think, Sham, can you give a heads up about it?
Yeah, we will talk about the EV integration. We have noticed in the previous sessions, customers were talking about power quality issues, and now we'll specifically address for the EV and after that the solar. So now, as we know, the EV or the deployment of EV happens in India at scale. At scale, what I mean literally is at scale. So when we say that there is two requirements when this happens at scale, is it safe? Is it going to impact my my grid from the electricity supply point of view? So from both of this perspective, we will wanted to address the next topic that will be about verification. We will also address some of the power quality issues or some instances where this is important for all of the people to address. I'll also give one more heads up, Joe. Maybe I'll take another 30 seconds or so.
Sure.
Because EV is an industry which is rapidly booming, but the ownership of the industry, from my point of view, is slightly scattered. What I mean, there is a vehicle manufacturer, charging manufacturer, installing company, and a public utility company. and the owner of the premises if you're commercially giving out for someone to go for a charging, which means there are 5 people who are involved, 4 5 different engagement agencies or companies are involved in one EV charging station deployment. So there is a absolute requirement to address it safely. We are always from the measuring equipment or the measurement point of view, and we think that is an important industry moving forward, which we wanted to address it from the measurements point of view. So I believe our next session will have more engagements, because it is not only for an electrical engineer anymore. My wife, if she want to ride a electrical car, she has to know what is it about. So it's going to be not only for an electrical engineer. Anyone who literally, I mean, anyone who are involved in the usage of this EV shall know some basic parameters about this EV. So that will be about the next session. Before I share or conclude my session, Joe, thank you once again for Blue and Gray team. You guys have been phenomenal. It's not possible to bring such large audiences without your effort. So thank you for all of your supports, and my team, and also the customer from railway who did spend his time to come and explain, because we just told him, sir, there are few questions from the other railway departments. Would you like to share? And he told, yeah, I'm but so that's kind of supportiveness and sportiveness from the customers, and sharing such kind of engagements is something that is keeping us moving and motivated. So thank you all for your engagement in the session, sir. Joe, over to you, please.
Yeah, thank you. Thank you, Shyam. Thanks a lot for your kind words. I've also attached the link for the upcoming webinar, and we do take feedbacks about our sessions. So if anybody has anything, please do write to the mail ID given in the chat box. And yeah, we can conclude right now, Shyam. Yeah.
Thank you so much, Joe. Thank you so much.
Thank
Thank you,
you. Thank you,
Mr.
everyone.
Dominic and Blue and Gray team. Thank you. Bye bye.
Thank you. Bye.